Right. Okay, good Friday morning, friends, and welcome back to the Backyard Naturalist series. My name is Tim. I work at the Urban Ecology Center in Milwaukee, Wisconsin, where there are currently sunny skies, house sparrows, and chickadees chirping outside my window, and the wind chill is right around zero. Uh, but I think by the time this ends, we will be at a balmy 5-degree wind chill or something like that. Today we're talking about ants, and I'm glad you're here with me. Thank you for accompanying me on this journey. And um, it seems like every week, if I don't outright say it, I'm probably thinking, how can I fit all the amazing stories from the spiders or maple trees or bacteria or whatever? How can I fit all these into 30 minutes or 40 minutes? And I usually say or think, wow, I really need to do a part 2, a sequel. And I realized very early in this journey with ants that fitting the ant stories into one episode was pretty much impossible. I'm also, I think, being joined by at least 2 of my own ants today. So welcome, Mary and Janet. And I'm telling you now that the Sisterhood of the Traveling Ants, this is part 1. And we're going to have a part 2 in March. And luckily for me, there is a Sisterhood of the Traveling Pants part 2. So creating there was a sequel for that movie too. So creating the title page shouldn't be that hard again next week. All right. Let me just figure out why my slide isn't advancing here. There we go. There we go. Okay, so I'll start with my weekly appreciation for all of the Backyard Naturalist subscribers. Thank you so much. I'm always humbled by your support, and I appreciate you more than you know. And a big thank you to members of the Urban Ecology Center, and a reminder that there are many benefits to being a member. And in February, UEC members get extra discounts at a really cool store on Bolete Street called Dandy. So check your monthly membership newsletter for details, or contact membership manager Glenna Holstein. Also, a quick reminder that every Tuesday, Wednesday, and Thursday, 52 weeks out of the year, you can help us collect data through the UEC Birdwalks at 8 a.m. So 8 a.m. on Tuesdays, we meet at the Menominee Valley branch and survey birds either through Three Bridges Park or along the Menominee River in front of Miller Park, AmFam Stadium. Every Wednesday at 8 a.m., we survey birds in my neighborhood, Park Washington Park, and every Thursday at 8, we do bird walks in Riverside Park in the Rotary Arboretum. So we're there every day, unless the weather is dangerous and some holidays, but you can ask any member of the UEC research team for details. We'd love to have you along. It's not intense or competitive. It's relaxed and social. One volunteer who's admittedly not religious described it as her version of going to church to relax and socialize while observing and studying nature. So again, if it's Tuesday, Wednesday, or Thursday at 8 a.m., our bird walk is starting at a UEC branch, and we'd love to see you. Today is February 18th, and a quick look at the human phenology side of the world tells us that today is a day of recognition of the Amami languages, the indigenous languages spoken on the Amami archipelago off the east coast of Japan. The number of speakers of this language, as well as the Ryukyu languages from the Ryukyu Islands off the southern coast of Japan, is unknown and generally restricted to people older than 50 because of a long period of government suppression of both languages as part of a forced assimilation program. It's believed that some of the only young speakers of the language are children that live with their grandparents who still speak it. And languages as a cultural identity can be endangered and go extinct just as a species can. Today is also Independence Day in the Gambia, as they mark their independence from the United Kingdom in 1965. It's National Democracy Day in Nepal, celebrating the overthrow of the Rana dynasty in 1951. Today is Kurdish Students' Union Day in Iraqi Kurdistan, and up in Iceland, today is Wife's Day or Women's Day, which has been celebrated for a really long time. Okay, so we can move on to ants right after I give a shout out to my main sources of this Western trivial information I focus on for most of the Backyard Naturalists, including this one. So Thank you to the How Stuff Works conglomerate, which includes the Stuff You Should Know podcast that I know Zeke listens to as well. And a special thank you to Zeke for drawing my attention to this episode. I'm also addicted to the Ologies podcast and Mental Floss, so acknowledging my main sources of information. So ants. There are a lot of ants, both in terms of individuals and numbers of species. We estimate that there are about a quadrillion individual ants in the world. That's 1,000 trillion, which is a number that some have pointed out to me sounds kind of made up. 1,000 trillion ants, 10 to the 15 ants in the world, and an estimated 14,000 species are described, with probably at least 10,000 more that we haven't yet met. In my tropical biology course, I look at species diversity of the tropics versus temperate zones, and E.O. Wilson collected 43 species of ants from one single tree in Peru. One tree, 43 species of ants representing 26 genera. They make up an estimate somewhere between 15 to 25% of all of the biomass on the entire planet. So if you took all of the living things, the elephants, the redwood trees, the whales, the bacteria, the krill, everything, put it all in one huge box, it's likely that 25% of the weight of that entire container is made up of ants. So there are some areas where ants make up half of all the insects. So with this huge beginning, where do we start? We'll keep it simple and start with one species of ant. So if you were to walk out of your house, probably not now, but in the summer, walk to the sidewalk, chances are the first ant you would come across is the pavement ant, also known as the sidewalk ant or Tetramorium immigrans. And like so many of the really common critters around our house, this one is not native to the area. It's native to Europe and Asia. But to then figure out this ant's place in this great tree of life, we don't have to go back too far in the Backyard Naturalist database, because we kicked off season 2 with an episode on yellow jackets. Yellow jackets are a type of wasp, and both wasps and ants are in the order Hymenoptera. Hymenoptera translates as membranous wing or hooked wing. Some ants do have wings, and so we go through all the kind of evolutionary history in that episode, and it's likely that the ant lineage evolved from the wasps, and more specifically, ants evolved from the mud dauber line of the wasps. So all of the ants are most closely related to the mud dauber wasps. And when you look at the two of them side by side, here we have a mud dauber wasp and a carpenter ant, you can see the resemblance pretty well. Wasps are pretty much flying ants, or ants are pretty much crawling wasps. But they both have similar body plans, and they can both pack a really mighty sting. And in that yellow jacket episode, we also go into why those stings are just so terribly cruel, the biochemistry behind it. But right off the bat, while ants can bite, and we're going to see some examples of some amazing jaws, it's not the bite that you have to worry about in most cases, it's the sting. But they can do both. And again, in the yellow jacket episode, we get into how stingers evolved from female reproductive parts. The ovipositors, the same organ that lays the eggs, also does the stinging. And so if you do get stung by a wasp or an ant, you know you're getting stung by a female. So while wasps proceed in the Apoidea lineage, the ants proceed in the Formicidae lineage. So Formica being the Latin derivation of the name of this group of species. Ants and wasps are both eusocial, and that's the highest level of organization of sociality. They are the original socialists, a colony of selfless individuals kind of working towards the greater good, giving up self to support the colony. So I don't know, for those of you political scientists there, socialism, communism, it's more detailed than I can think of. And, you know, it's fun to anthropomorphize, but sometimes that helps you understand better, but you also have to realize what you're doing. And ants are something that we really, really, really don't understand behaviorally, how they do some of these things. And we're going to get into that over the next 2 episodes. So you have a colony with sterile females and a caste system with workers, so soldiers, drones, and queens. And this photo represents all of the different castes of the leafcutter ants. And this social system allows them to solve highly complex problems through communication between individuals without somebody calling the shots. I mean, they're protecting a queen, but there's not one leader, and they're still able to solve some of these really complex things. And they've been around for 130 million years, since the Cretaceous. So they survived the massive KT extinction events. They're everywhere, essentially dominating most terrestrial ecosystems of every continent except, surprise, Antarctica. The name ant likely translates as the biter, even though, again, it's usually the sting you have to worry about, not the bite. And if there's one really important takeaway from today, ants are, besides super cool, they're tremendously important to plant and wildlife communities, ecological communities, even just from a purely functional point of view. So they move massive amounts of materials and energy up and down from the canopy to the soil through the trophic levels. They're omnivores, so they consume both plant and animal material. They're food for other carnivores and detritivores, and they even move more earth than earthworms do. If we look at the basic body plan of the ant, and starting with the head, so they have eyes. The eyes are either compound eyes with individual lenses that then combine to make an image in the central nervous system. So that's like the ant in the top photo. Or they have ocelli, which are simple eyes that really only distinguish between light and dark. So army ants, for all of their ferocious behaviors, are pretty much can't see other than just light and dark. And then, so some ants, like the one on the lower right, have both senses. But even the ants that have both the simple and the complex eyes, almost to a species, ants are not visual sensors. They also have these 2 antennae, and it's those antennae that both smell and hear, and it's the primary mode of ant communication, which is through pheromones. So they don't have ears, but they're able to sense vibrations with an organ that's located below the knees in their legs. They have a mouth because they got to eat, and they have mandibles because they got to get the food to eat. And sometimes those mandibles can be large and scary. So on the left, we have the appropriately named bulldog ant, and on the right, we have the bullet ant. So one of the things that separates both of these species, among others, is that they can get you both ways. They can get you with a nasty bite, and they can get you with a nasty sting. So the bulldog ant is responsible for at least 3 human deaths. And usually that happens either if you're overwhelmed by ants or if you're allergic to the venom. And that's the same with wasps and ants. And then the bullet ant has been used by some communities historically as stitches for cuts. And I'm not kidding. They're like the pit bulls of the ant world, because once they clamp down with those mandibles that are sizable, it's almost impossible to get them to unbite. So if you have a wound, a cut, and you have to suture it, and you don't have stitches, you can literally use the bite of the bullet ant or an army ant or even a leafcutter ant soldier to close the wound. So first you have to grab the ant, hopefully without getting stung, especially in the case of the bullet ant. Then you have to be brave enough or dumb enough to get the ant to bite you on either side of your cut. And then once it bites, you can remove everything except the head, which will then remain in the clamped mode and act like stitches while your wound heals. So I don't recommend this unless it's the only first aid you have available and you have to save your life. A, because it's crazy, and B, because it's cruel to the ant. And if you don't believe me, I'll show you the end results of this process. So if you're squeamish, you may want to look away from the screen for a moment. I'll give you that warning. But here is a picture of someone who used army ant mandibles to close a wound. So you can see 3 heads and 10 are still attached to the head, but the body is not. And this is way more common, both geographically and historically, than I realized. Cultures have been using this around the world for a long time, but it makes me celebrate and appreciate modern first aid techniques even more. Okay, if you were looking away, you can look back at the screen now, although this is also kind of scary. Staying on the bite theme for a moment, before we move on to the fun stings. The Latin American trapjaw ant has a very interesting way to use its mandibles for things other than catching food. It will use them for a quick getaway, for locomotion. So essentially, if the ant bites the ground or anything that's too big to fit in between the mandibles, the force of those jaws closing propels its body back or up through the air several inches. And so that can be a defensive mechanism to get away quickly from something, propel itself through the air away from danger, similar to how a flea uses its legs or a springtail uses its tail. And the bite of the trapjaw ant used to be considered the fastest bite in the animal world until it was discovered that another ant, the snapjaw ant, took over the title. The snapjaw ant likely has the fastest movement in the entire animal world, all the animals, faster than a snapping turtle head moving forward to catch something. The acceleration of the mandibles is more than 100,000 times the force of gravity. The mandibles move at 200 miles per hour with a force that's more than 500 times the weight of the animal. So it's in this amazing context that we'll move on to our first video.
This ant goes from 0 to 200 miles per hour in 0.000015 seconds. Researchers have just described this bite as the fastest animal movement on record. Its name is Mystrium camillii, a type of Dracula ant found in the Southeast Asian tropics in Australia. Scientists set out to describe its snapjaw movement, characterizing performance and analyzing jaw shape. Their jaw snaps begin by pressing the tips of the mandibles together, bowing and spring-loading their jaws. They release when the fast, striking mandible slides over the slower, loading mandible. To visualize these snaps, the researchers had to film the ants at 480,000 frames per second. Peak snap duration measured at 23 microseconds and peak velocity was 200 miles per hour, which makes them 5,000 times faster than the blink of an eye, 1,000 times faster than the snap of a finger, and 3 times faster than the snap of the trapjaw ant, the former fastest ant on record. Compared to a closely related non-snapping species, snapjaw ant mandibles are flattened, allowing them to bend and act as a spring, powering the high-speed snap. Meaning small changes in jaw shape have helped these ants reach incredible speeds. Whether these ants have evolved their snouts for predation or defense remains unknown. Much of their biology is undescribed. For now, we know that Mystrium is redefining the limits of animal speed and helping us understand mechanisms behind fast animal movements.
If you want to hear more about this research from the scientists themselves, click here.
Okay. So they mentioned that the movement is 1,000 times faster than a snapping finger. And snapping your fingers, I believe, is the fastest movement that we as humans can do. So both the snapping finger and the snap of the snapjaw ant, they use friction to build up that potential energy. So using the friction in your fingerprints, and then you release that energy all at once. So try this sometime, or right now, if you can snap your finger, try to watch the movement of the finger that's snapping. You can't. I promise you, unless you know a way to like slow snap, our eyes don't process images fast enough to see your own finger during that regular slapping motion. So your finger's in one place and then instantly it's in another. It's like a photon. It's super cool. So just try that. You can't, it's really cool. Okay, so whoops. What's this always happens?
This ant.
All right. We've seen some ants so now with very powerful jaws. But the real punch from ants comes from the stinger, like this bullet ant. And the bullet ant is widely considered the animal that gives the most painful sting of any animal in the world. And how do we know this? So I will introduce you to Justin Schmidt. Schmidt is an entomologist who primarily studies the Hymenoptera, stinging ants, wasps, and bees. And he has made a name for himself because in the course of his research, he estimates that he's been stung over 1,000 times. And at some point during all the stinging, he thought, well, as long as I'm getting stung all the time, I might as well try to harness that pain into something useful. And so as he travels the world in his research, if he gets stung, he makes sure to describe the pain in both words and on a pain scale. And I'm glad I did the research because I just thought that this was someone who just decided this was going to be their thing. They're just going to go out and sting themselves like for fame. But no, this was somebody who's doing research and like, oh man, I just keep getting stung. So what can I do with that stinging? So you may have heard of the hot pepper index to describe the pain of eating certain peppers. And then this regular pain index that nobody likes to see because it probably means you're in the hospital. The work of the entomologist, Dr. Schmidt, who just kept getting stung, led to the Schmidt insect pain index scale. So if he gets stung, and again, he doesn't want to get stung, but if he gets stung, he rates the pain on a scale from 0 to 4. 0, of course, would be no pain. And then 4 would be unbearable, excruciating pain. And then he also pays attention to how long it takes for that peak pain level to subside, probably as he's rolling on the floor in pain. And then my favorite part of the whole process is the words he uses to describe the pain. So you can see here from scale to 1 to 4, and then the size of the circle, it's not to scale, but it's an indicator of how long that the peak level of pain lasts. So again, level 0 is no pain. And then here are a couple examples of insects with level 1 pain. So the sting of the sweat bee and the sting of the red fire ant. And the sweat bee was, so I mentioned he didn't want to get stung, but there's some animals that to help with this index, he actually had to get them to sting him. And interestingly, the bullet ant, which again is probably the worst, very likely won't sting you. You can let them crawl on you. You can, but if you do like, push down on it or accidentally grab it or something, then it will sting you. But so the sweat bee was one of those animals that he had to try to get to sting him because they really just don't want to sting humans. And to induce the animal to sting, they usually do that just by pinning down the animal down to your skin. And so Schmidt describes the pain of the sweat bee sting as light, ephemeral, almost fruity, as if a tiny spark had singed a single hair on your arm. And so a lot of people that follow Dr. Schmidt often compare his words to describe pain as words you'd use to describe wine, like at a wine tasting. So sweat bee, light, ephemeral, almost fruity. I've never experienced the sting of a sweat bee, but I have been stung by a fire ant, and I can attest to the fact that it hurts. So I was surprised that it ranks so low, but I also don't have a very big tolerance for pain. But then Josh and Chuck in their podcast point out that this is the sting of a single ant, which is very different from what usually happens with fire ants. When this happened to my mom, you don't realize you're standing in a nest of them, and then all of a sudden they start stinging you in bigger numbers. So there's a lot of them. So that's different, being stung by a lot than being stung by one. But Schmidt describes the pain as sharp, sudden, and mildly alarming, like walking across a shag carpet and reaching for the light switch. And so essentially he's comparing the sting of the fire ant to an electric shock. And in his mood, I'm surprised he doesn't describe the color of the shag carpet. But one of the things I love about this picture, particularly of the fire ant, is that you can see that the fire ant is both biting and stinging at the same time. And if you are unfortunate enough to find yourself standing in a fire ant nest and they start stinging you, word on the street is by Chuck Bryant of the Stuff You Should Know is that the best way to rid yourself of fire ants is to brush them off. Don't pour water on them because that just causes them to bite down harder. So fire ant, sweat bee, sting level 1, and the pain of the fire ant subsides in about 5 minutes. And it's also important to point out here that these pain levels don't take into account allergies, because if you're allergic to the venom, that's an entirely different story. Most of the insects on the Schmidt pain index fall in a level 2, and that includes the familiar bald-faced hornets and yellow jackets. So bald-faced hornets are the wasps that make those papery globe nests that we often see on bird walks and you see outside. The one that I used to think were paper wasp nests. And then the yellow jackets are the, what did Jenny call them? The flying jerks, the ones that you love to hang out with while you're in, outside eating food and they're just bothering you. Both of these insects are very common in our green spaces. And Schmidt describes the pain of the bald-faced hornet, which lasts about 5 minutes, as rich, hearty, slightly crunchy, similar to getting your hand mashed in a revolving door. And it's those extra words that really help, like the shock or the crunch, because even though both of these animals are a 2 on the index scale, the pain of their sting is, according to Schmidt, very different. So he describes the yellow jacket pain as hot and smoky, almost irreverent. Imagine W.C. Fields extinguishing a cigar on your tongue. That's not what I thought of when I was stung, on the end of a yellow. I've been on the stinging end of a yellow jacket many times, including 3 times this summer. And yeah, it hurts. And it hurts more than a fire ant. I've been stung by both. And the pain lasts twice as long, according to Schmidt, 10 minutes on average. And the length and strength of the pain depends on how deep that stinger embeds into your skin. And for me, it's usually that itchiness and swelling of the yellow jacket that lasts far longer. All right. Moving up a notch to level 3, we start to get serious, and we get into territory that I have no personal experience with. So we move up to the harvester ant and the paper wasp, among others. The paper wasp sting is, I love these, is described by Chuck Bryant's daughter as caustic and burning with a distinctly bitter aftertaste, like spilling a beaker of hydrochloric acid on a paper cut. And of course, she said that after a nice long bout of screaming. And the good thing about a paper wasp, and the good thing about some of these, so the paper wasp, it only lasts 15 minutes, which probably seems like a lot more, but then the pain completely subsides. And that's not the case with the harvester ant, which is also a level 3 and has, according to most sources, the most toxic insect venom in the world, 40 times more powerful than the Western diamond rattlesnake. But it's not usually deadly because they inject so little of it. A lot of pain, but it's probably not going to kill you. And Schmidt describes the pain as bold and unrelenting, like someone using a drill to excavate your ingrown toenail. And Chuck Bryant describes the pain as if there were a thumbtack pressed to the ridge bone in your eyebrow and someone was tapping it with a ball peen hammer, which makes me think that all of these people were probably watching some old Saturday Night Live shows as they're describing their pain, or these venoms just go right to their brain and just cause you to start being overly poetic in the descriptions. But the pain from the sting of the harvester ant is extremely long lasting. And due to the complex biochemistry, it causes the hair on your arm to stand up, which is something that I probably wouldn't notice or care about. But there's a lot of potential in studying this really complex venom, and there's a lot we don't know about how it works. And then after 3, there's only 1 level left. So we'll start with the tarantula hawk, which is a level 4. The tarantula hawk is a type of wasp that paralyzes tarantulas and then lays its eggs on the body, and again, using the same organ to do both. And then at some point in this research, I became aware of a huge social media culture that I wasn't aware of, but doesn't surprise me, where people film themselves getting stung, and it's really, really popular. And this is what's happening in this photo. So there's I watched a clip of a man called Coyote Peterson who filmed himself getting stung by a tarantula wasp. That video has more than 60 million views on YouTube. And when I went to tell my kids about it at dinner, I was like, oh man, I was just watching this guy and it was Coyote something. And then Henry was like, oh, Coyote Peterson. Yeah, I subscribe to his YouTube channel. So apparently everybody knows about Coyote Peterson except me. But Schmidt says that if you ever get stung by tarantula hawk, the best thing to do is just lie down and scream because the pain is so debilitating and the screaming is the most satisfying thing you can do. He describes the pain as blinding, fierce, and shockingly electric. But the merciful part of it is that this intense pain subsides after 5 minutes. So just make sure you have a good 5 minutes of screaming in your lungs if you get stung by this critter. For the bullet ant, the pain was so excruciating that he had to actually expand the index beyond 4. And so the bullet ant receives a 4+ rating. And unmercifully, this pain lasts for 12 hours. So the most intense stinger also is like the longest lasting, 12 hours. So he describes the level 4+ pain of a bullet ant sting as the holy grail of stinging insects. It's pure, intense, brilliant pain, like walking over flaming charcoal with a 3-inch nail embedded in your heel. And many describe the bullet ant sting as the most painful sting in the entire animal world. And a friend of mine in Costa Rica was unlucky enough to get stung by one, and she said it was way worse than childbirth, which many of us can't relate to, but can only imagine how intense that pain is. So I think it's interesting that Justin Schmidt became known for something, but he didn't do it like these YouTubers, like for popularity. And he still grapples with the fact that he wants this data, but he doesn't want to be stung. And he mentioned that in an NPR interview. So, for me, that's super easy because I don't want the data and I don't want to get stung. But I do have this just like always a pause. It's like, I don't know if it's innate curiosity, but when I do see something that I know will be really painful, I do for just a few seconds think, I wonder what it's like, but it's only a few seconds and then that urge passes very quickly. I don't need to know. But one result of his kind of competing urges to get data, but also not to be stung, is that there are some insects that are not yet on his scale. I think there's 80 or so insects on the scale now. So we don't know what they are on his scale, but there are plenty of other crazier people out there that have been stung by some of these insects, like the executioner wasp and the giant mandarin Japanese hornet, also known as the murder hornet. So you can watch people get stung if that's something you like. You can start with this Coyote Peterson person on YouTube, but we just don't know what they are on Schmidt scale. I imagine they're pretty bad 4s. But again, we're talking about ants, and the undisputed king of insect pain as we know it remains with the bullet ant. So quickly back to the basic ant anatomy, 3 parts, but instead of the head, thorax, and abdomen that we learn about, ants are a little fancier. They go by head, mesosoma, petiole, sometimes postpetiole, and gaster. So we've already kind of talked about the head. The mesosoma is that middle body section that's attached to the legs, super muscular. The petiole is the waist of the ant, the bendy part, and then it connects the mesosoma and the gaster, just like the petiole of a leaf is the thin part of the leaf that connects to the twig, the leaf to the twig. And again, sometimes the ant has 2 petioles, 2 bumps, the petiole and the postpetiole. And then the gaster is essentially the abdomen, and that's where the heart and reproductive organs and stinger are located. The respiratory and circulatory systems are very similar to the spider. They've got spiracles with tubes that open up into them for oxygen, and then movement helps with that. They have the kind of basic pumping heart and 2 stomachs. So one does the eating and digestion for itself, and then one stomach they use to share food with others in this highly social society, and that process is called trophallaxis. And you may remember that from when we talked about wasps, and adult wasps will bring back food to the larvae and regurgitate it. And this process also happens in ants because, there's some ant casts that never leave the colony, but they still need to eat. So a worker ant will bring them food from their second stomach. The outer exoskeleton of the ant is much tougher than the exoskeletons of a lot of the other invertebrates we've talked about. So this coat of chitin armor can withstand a force 3,000 times the animal's body weight. So they have a super strong shell, the armor, and their muscles, which we're also studying, are extremely dense and extremely strong, particularly for an animal of its size. So they can carry incredibly heavy objects, up to 50 times their own body weight. And if you do the math, that's like us carrying around an adult hippo on our shoulders, which weighs about 7,500 pounds. So ants can bite, they can sting, they have this tough shell, they're incredibly strong. The family Formicidae has the same root as formic acid, and formic acid is something that ants can spray out of their abdomen as either a defense or an offense. And we'll see this in our next video because it's David Attenborough. And I apologize, the quality of the video is a little poor, but we can still swoon at his voice and again, get the gist of it.
Building a huge nest like this is that you're very obvious to predators. But these ants have a very effective way of defending themselves. Watch. The unmistakable acrid smell of formic acid. Most ants, like their wasp ancestors, have stings, but not these wood ants. Instead of injecting poison, they squirt it, and very accurately too.
So that formic acid they spray is both the defense, but it's also used in an offense, if that's the right word. If there's battling ants, if they can get that under that chitin level, that acid will just kind of eat out the ant from the inside. It's pretty gruesome. And if you go to Australia and you find the green weaver ant, you get an entirely different kind of acid.
Building a huge nest like this.
So here's the ant spraying the formic acid. But the Australian green weaver ants, their acid has an entirely different odor and taste. And you may have heard of ant licking being a thing in Australia. And I'm not talking about the ants doing the licking. I'm talking about humans licking ants, because the green weaver ant produces an ascorbic acid or vitamin C that has a nice, refreshing, citrusy taste. And indigenous cultures actually make up concoctions of these green weaver ants when they're fighting a cold, much like we take vitamin C, or some other indigenous cultures will make a concoction out of sumac berries to fight colds, because sumac also has ascorbic acid, just like the green weaver ants of Australia. So I don't know, you might want to consider adding licking ants to your bucket list. Just make sure it's not a bullet ant. Next, we're going to look at a couple of the ant behaviors that fall in the how can this be real category, starting with the story of how ants are some of the best livestock herders around.
Hey, Tim.
Yeah.
Before we move on, quick question about the acid. Does it run out after they squirt it, or going?
I don't know that level of detail, but I'm going to find out how quickly they can recharge. It's an excellent question. Thank you for that question. Ants are amazing livestock herders. And this story starts with aphids. So aphids are insects that you might be familiar with. Sometimes they find their way into your house plants or garden plants. Aphids make a living sucking the juices out of plants by tapping into the plant's phloem ducts and kind of basically drinking that. But as we witnessed in our spittlebug episode, from season 1, usually immediately after they suck the plant juices or soon after, they release a kind of sweet nectar. And it's really pee, but maybe better to think of it as nectar. We call it honeydew. And I bet you can't guess which animals go crazy for honeydew. Yes, it's ants. So many species of ants drink that honeydew bubble right up. And, you know, you might first look at this picture and think, oh my God, what is that ant doing to that poor aphid? But upon closer inspection, the ant is just drinking the honeydew nectar directly from the aphid's rear end, which maybe means you're still thinking, what is that ant doing to the poor aphid? But she's definitely not eating it. Ants love to drink that aphid honeydew. And they love it so much that ant colonies will search for aphid colonies. And when they find them, they will essentially domesticate them and tend to that colony because they value it so much. And very similar, how do we tend to livestock? So by day, the ants let the aphids roam on the plants. They let them out and graze, and they still protect them because, you know, ladybugs love to eat aphids, and they value them. So they're protecting them. And then every once in a while, an ant will go up to a honeydew and stimulate it to produce that honeydew bubble. And then they'll drink it. And, you know, it's kind of like we're protecting dairy cattle. And then every so often we put a bucket under their teats and stimulate them to produce milk for us. So strikingly similar if you think about it. And we can see this process in action in this very short video. So now the ant is stimulating the aphid to produce the bubble, and it drinks it right up. All right. And then it's just so crazy because so they'll let them out in the daytime. And then at night, the ants will actually herd the aphids back into these protected roosts, just like we herd cattle into a barn. And then the following morning, they let them out again to graze on the plants. So it's pretty crazy. On the slightly more nefarious side of ant behavior, there are also cases where ants, they don't tend to other species, but they actually capture them and essentially force them to work for their own colony. And then the captured ants are working for their captors. But then often there are essentially rebellions where the captors will rebel against the captors and then return and kill them and then return to their own original colonies. So you kind of see the gentle, caring side of ants working with other species, and then this kind of dark side of ants enslaving other species. And so since I have to stop somewhere, and again, we got a whole another episode of stories, I'm going to wrap up this program with a moment of Zen as we return to these trapjaw ants.
This is a trapjaw ant falling face first, and right here, it's about to do something incredible. Let's roll it back and watch. The instant before the ant hit the ground, it snapped its jaws and flung itself back into the air. And how it managed to do that is actually a pretty interesting part of its biology. Trapjaw ants use their spring-loaded jaws to do a lot of things, like catch prey or launch themselves out of a dangerous situation. But to do any of that effectively, the ants need a way to time their snaps and know when their targets are within striking distance, and that's why they have these. At the base of each jaw, 2 long trigger hairs that stick out in front when the jaws are open. When these hairs are stimulated, they send the signal to release a snap. You can see them in action in this clip. As the ant approaches my finger, the hairs are projecting out in front of its mouth. When they make contact, the ant knows it's in striking distance and releases its snap. But there's more to this story than these hairs automatically triggering a snap every single time they're touched. Workers will often hold their jaws open around each other, some even loaded and ready to snap. But when they're bumped into by nestmates, they don't snap. These hairs only act as triggers when the ants are in the right motivational state. Otherwise, the signal from them isn't enough to actually release a snap. You can see how that works by actually looking inside the ant's head and looking at how these hairs are wired. Giant motor neurons from the hairs split into huge dendritic trees that integrate other mechanical and chemical inputs. The signal from the trigger hair alone isn't enough to activate the trigger muscle and release a snap. The ant has to have other sensory cues telling it it's in the right situation to release a snap. So, a falling ant is able to snap and bounce back up for a few reasons. It knows it's been picked up off the ground or pulled out of its nest, and usually that would mean it's about to be eaten. It also knows it's falling, so it's a pretty good bet that the next thing the trigger hairs touch is worth snapping at. The acrobatics are a reminder of how powerful their jaws are, but also how little intricate details like trigger hairs allow them to do amazing things.
So really, I just showed that video because I just want to end every program now with bouncing ants. But that is it for part 1. And I thank you for joining me, and I will stop sharing my screen and get to